Now we'll be starting with the topic that is the chemical reaction. So before we proceed, now you know that what exactly is the chemical change. We have done that is that in a chemical change a new substance is being formed, and you know that there is a change in the composition as well, there is a change in the energy as well, and the change is irreversible and is a permanent change. So those all conditions are applied in the case of chemical reaction, because chemical reaction happens at the cost of chemical change. So just look at the board that we are starting with the new topic, that is the chemical reaction. Now what is the chemical reaction? Chemical reaction is actually a process. Before I take up a, you can say a bookish definition, I just want you to know that how the reaction is happening in a daily life. So I take an example. See, we take water. When you get some guest at your place, then what you do? Your mom asks you to make the tea. Then what you do? You just take a pan, add water to it, add tea to it, add sugar to it, and add milk to it. Then you heat it, right? You heat it, and then as a result, what you get? We get tea, right? So this is the reaction, the example I have taken from the daily life, because see, the chemistry actually revolve around the daily life. All those things which we are doing are just are happening due to science. So whether it can include the chemical science, or it can include the physical science, or it can use some other analytical concept. So it is just the chemistry, as we discussed, that chemistry has a wide scope. So just focus on the topic we are doing, that is the chemical reaction. Chemical reaction is a process in which you add certain substances which gets rearranged and just form a new substance. So the chemical reaction, I am just repeating a bookish language for you so that it will be easy to recall. Chemical reaction is a process in which few substances react, undergo a change, and just get rearranged to form a new substance, that is called as chemical reaction. So the substances that react are called as reactants, and the new ones which are formed indicated by the arrow, which means they unite to form. They just turn into this, alright, to form products. So this is the way how, this is actually that what does chemical reaction means. So chemical reaction is a process in which the reactants, so instead of using few substances that I was using in the previous term, so just redefine it, because up to as your level increase, the way of expressing your answer should be very efficient. So just use the word reactants now. So chemical reaction is a process in which the reactants undergoes a change. They may rearrange, or they may combine, or they may just add, or any kind of change they are undergoing and just giving rise to the products. So this is a chemical reaction, right? So how chemical reaction is, now the question comes, how chemical reaction is represented actually. So there is a two method to represent the chemical reaction. One is the word equation method, and the other is the chemical equation method, right? So one is the word equation method, the other is the chemical equation method. Now I am taking one more example. So if I say that carbon reacts with oxygen gas to form carbon dioxide, so I can write the chemical reaction in the form of word equation, as I have written for this C plus O2, this thing, carbon plus oxygen gas to form carbon dioxide. So in this way, when you are writing like this, so it means it is a word equation method to represent a chemical reaction. But now when I am using the, you can say the symbols for the elements, I am specifying the states, I am just just trying to reveal the whole information about the reactants and the products, then we do in a chemical equation method. So I can write the carbon as C, oxygen as O2, which gives to form CO2. So to make it more informative, I am writing the states See, carbon occur in solid form, oxygen occur in gaseous form, and carbon dioxide is again in a gaseous state. So this, now by writing this, the reaction has become more informative. So you can make it more informative. So like how you can just balance it. As you can say, it is already balanced, but in case if it is not balanced, we can just react the balanced chemical equation. See, I'm taking up another example. Just look at it. I've written the symbols, then I have specified the states, right, and now I'm just balancing, because we know according to law of conservation of mass can neither be created nor be destroyed. The mass of reactants are always equal to the mass of product. It is just a law of indestructibility of matter which is followed by the matter, right. So I'm just balancing it because that law is being proved. So we need to balance the reactants, the mass of reactants with the mass of the product. So there is 2H, 2O, but 1O. So I'm just putting this 2O. So now the mass of reactant is same as mass of product. You can say there are 4H and atoms, and this side, the product side, there are 4 atoms. Similarly, there are 2 atoms for oxygen and there is 2 atoms for oxygen. So you can make this way, you can make the reaction more informative by writing the formulas, by specifying the states, by balancing them, and even if there is some precipitate present, so just indicate that this is the precipitate by just putting the arrow downward, right. And if sometimes there is a gas, you can make the reaction more informative by just putting the gas, the arrow pointing upside, which will show that the gas being volatile will escape, right. And to make the reaction more informative, we have few more things, like just write the names also, like I've used this carbon, so write carbon, like this is oxygen, so mention oxygen, mention the name of the product. So just make it more informative, and even you can write the colors. If some colored compound is present, so you may write the color also, that yeah, it is blue colored, like iodine is mostly of yellow color. So wherever you use that, you can write that it is of yellow color, the crystals lead iodide or something like that. So this is the method, a better method to explain the chemical reaction, to represent the chemical reaction, because by looking at just the reaction, we can get to know that what has actually happened, that this is combined with this, how many moles combined with this, what are the forms, what are actually they are forming. So it is just the chemical equation method is the better way to represent a chemical reaction. Always keep in mind that chemistry works on the basis of chemical equations. So whenever you are attempting any questions or something, or you are answering something, so just try to give in a chemical equation method, because more you will use the equations, you will be more clear from your mind that what is actually happening, and the chemistry is better understood with the help of the chemical equations and the chemical reactions. So like if I ask you what happens when zinc rod is dipped in copper sulfate solution, so instead of answering in a whole paragraph that yes, when you add zinc rod to the copper sulfate, this, just straight away say Zn plus CuSO4, Zn being more reactive will displace copper and will result ZnSO4 plus Cu. So this is the better way to answer the questions in the chemistry. So more you will practice the reactions, more you will practice the molecular formulas and the valency, you will get to do that. So definitely you can do that. The only thing which is lacking, that you are not well versed with the valencies, that is why you are scared with the molecular formulas. So once you will have a full command on the valencies, you will be able to do the molecular formulas in a quick way, right. So just concentrate on the valencies, because they form the basic part. If you are familiar with the valencies, you can write the molecular formula, you can tell the chemical reactions on the tip, right. So coming to the point, so I've told you what actually the chemical reaction is, and we have also done that how chemical reaction can be represented. It can be represented by word equation, but the better method is to mention it with the chemical equation, in which we are using the symbols and all to make it more informative. Now, I think you know this now, that what the chemical reaction, what are chemical equation, and what do we mean by the word equation. Now coming to the point that what kind of chemical reaction do we get to see in nature, or how many types of chemical reaction can occur, can a matter undergoes. So there are many chemical reactions which are seen. We'll be taking one chemical reaction with the complete explanation. So just carefully look at the board. So we are first starting with the combination reaction. As the name suggests, what do you mean by combine? Combining is just that you are just adding those substances and they are just getting combined with each other. Nothing is getting eliminated, everything is just combined, just added to it, right. So combination reaction is a reaction in which we add certain substance which just unite to form a single substance. Nothing is eliminated. Just keep in mind that in combination reaction you add many things. You can add 2 things, you can add 3 things, because 2 is minimum and maximum you can take up to any level. But the only criteria for the combination reaction, that means they will be combining with each other, nothing will be eliminated. As many as reactant you add, they will unite to form a single product. As we did, as we were making the tea, what we did, we were adding the water, we were adding the milk, tea, sugar, everything just combined to form tea. Nothing was liberated. So that is also a combination reaction. So whenever you are adding you're just adding the reactants and they are just mixing with each other to form a single substance. So that means the occurrence of single substance on the product side indicate that it is a kind of combination reaction. Now, the second thing you should know that which element or compound can undergo a combination reaction. So, it should be clear in your mind that combination reaction are shown by the combination between element and element. It can be between element and compound, and even it can be between compound and compound. That means combination reaction can be shown by any of the 3. Element and element can also combine to form a single product. Similarly, element and compound can also combine, and similarly compound and compound can combine. I am just writing an example for you to make it more clear. So, we will have an example in which we are using the elemental states. So, for example, I am taking this H2 plus O2 forms H2O. See, this is an element, and this is a compound. So, this is the combination at element level, right. So, now as we are looking for the second example now, element and compound. So, that means we need one element and one compound. So, SO2 plus O2 in presence of vanadium pentoxide which act as a catalyst to form SO3. You can see in this case they are just uniting to form a single substance. So, that means obviously it is a combination reaction. Now, it is a compound and it is a element. So, that means the reaction can happen at element and compound level also. Next, we need a reaction in which 2 compounds are shown to combine with each other to form single substance. So, the example which is striking in my mind is SO2 plus H2O. So, what is it is going to form? It is going to form sulfurous acid. So, see, it is a compound and even it is a compound and even it is a compound, because when the elements will combine, they will definitely form a single substance, and the single substance is obviously at any time, whether in this case or in this case or in this case, whenever 2 or more elements react, they form a compound with definite ratio of mass and volume. So, all these are compounds. That means a single product that they are forming is compound, but the reactants can be the element, can be element compound, and can be compound. So, that means the reaction can happen at any level. 2 elements can combine, an element and a compound can combine, and even 2 compounds can combine to give a single product. The most important thing which we have to keep in mind is that whenever the reaction is undergoing that means whenever the combination reaction is occurring, the identification property for that combination reaction is that a single product will be formed, right. So, whenever you get to see that whenever you get a question that indicate that what kind of reaction is that, just look for it. If you have a single product, that means the reaction is a combination reaction. So, the second type of reaction we are taking up is the decomposition reaction. So, what do you mean by this word decompose? You are already familiar with the word decompose. You know that microorganisms are natural decomposers. What they do? They just act on the dead and decaying matter and just convert them into the more simpler matter. Similarly, we are using this word here, decomposition. So, decomposition is a reaction in which a compound, because we know the element can't be split into the more similar ones. So, in this case, the reactant is always going to be a compound, right. So, what do you mean by decomposition? It is a reaction in which compound breaks up into its constituents, means there will be a compound. It can be AB, it can be ABC, it can be ABCD. That means it can be it can be formed from many elements. Minimum 2 elements is required to form a compound. It can have more than 2 elements as well also. Then what will happen at molecular level? It will be due to any this thing factor. We'll be discussing the factor later. So due to any factor, it will be getting decomposed into its constituents. This constituents can be A plus BC, or it can be AC plus B, or anything like that. So the identification property of decomposition is that you are going to have one reactant, definitely a one reactant. The two reactant cannot occur in decomposition reaction, and definitely the product is going to be more than 2, minimum 2, or it can be more than 2. So for example, now the question comes that why this compound is getting decomposed. If it is getting decomposed by itself, so why it is occurring in nature, how such kind of thing is stable in a nature. So that means this decomposition do not occur at its own. We need to supply certain, we need to involve certain conditions for this reaction decomposition to occur. Now what are these factors under which the decomposition can occur? It can occur in presence of light, it can occur by passing electric current, it can occur in this thing, it can occur in presence of light, it can occur in electric current, it can occur by passing heat. So whenever the decomposition is occurring due for, at the sake of light, we call that decomposition as photo decomposition. Photo means light, decomposition again you know the reactant gets split up into its constituents, right. And if the decomposition occurring at the sake of electric current, then it is called as electrolytic decomposition. So that means electric current is being passed, then the substance is getting decomposed into its constituents. And if it is occurring due to heat, then it is called as thermal decomposition. It can also be called as dissociation, because we can use the word dissociation as well. So it can be thermal decomposition, or you can say the thermodecomposition. Now we'll look for the examples involved. So for light we have an example which is coming in my mind is that AgCl. When we are keeping silver chloride, suppose I am taking a dish and I am keeping the silver chloride in it and just keeping in this sunlight, what will happen? It turns into the silvery grey because it gets decomposed. So see, one reactant is being used and minimum 2 products are formed. So that means a reaction is again a decomposition one, because when 2 or more products are formed, then the reaction corresponds to a decomposition reaction, provided that there should be a one reactant, right. And we are just taking an example of electric current. Suppose we took this example before also. So when I am passing an electric current, it is getting dissociated to form H2NO2, right. And for heat, CaCO3 is being heated, it is forming CaO plus CO2. You know why I am using the same examples again and again? Because I want that you should have few chemical reactions in your hand, because once you will have few chemical reactions in your hand, you will get to know, or you will have the idea for the many other chemical reactions. So just be first well versed with few examples, then you will automatically have the idea how this happens and this is going to take place, right. See. So again, coming to the decomposition, that means a compound gets break into its constituents, minimum 1 reactant, more than 2 product, and minimum 2 or more than that. How it is getting decomposed? In presence of light, by passing current, or by the supply of heat. So this is how the decomposition reaction occurs. Now you will be surprised to know that okay, you tell me that can you figure out some kind of can you relate the combination reaction with the decomposition reaction? Tell me, can you see any difference or any similarity in them? Just look at the board carefully. Just notice many reactants, one product. In this case, one reactant, many products. So do you have some idea what I am talking about? Yeah. I think the idea must be striking your mind. You must have got the answer. Yeah, I am talking about this factor that the decomposition reaction or combination reaction, whatever we can start with, is actually the opposite of the other one, right? See, in combination we have got many reactants but one product. But in decomposition, we have got the one reactant and many products. That means these two reactions are related to each other. In it, the one reactant is used, and in it, many reactants are used. It corresponds to two or many products. It corresponds to only one product. So it is just you can say the opposite of the combination reaction. So if you get a question like that, why combination reaction is said to be reverse of decomposition or vice versa like this. So just write the definition first, then explain it with the general equations, because whenever you are studying the reactions, you just get to know the general equation, because once you are cleared with the general equation, you can easily formulate an example by your own self. Just you need to recall the valencies, that's it, is required in the chemistry. Right. So just write the general equation, then just explain it by taking an example, and try to take an example in which you can show the reverse also. See, I am taking an example for you the way I am telling you to attempt. See, I say that I am taking a CaCO3, I am just heating it and it is forming CaO plus CO2. So that means obviously it is a decomposition. It is indicating a decomposition reaction. And what kind of decomposition? Heat I have given, so that means thermal decomposition. Now I am just illustrating that answer with the same example. So I say when I add CaO to CO2, it forms CaCO3. So see, this reaction is just reverse of it, and it is a combination reaction. So what is happening? Here CaCO3 is breaking up into CaO and CO2, and in this CaO and CO2 is just united to form CaCO3. My point is just that whenever you get this answer, try to write the answers by taking a single example in which you can show the decomposition as well as you can show the combination. So this is how we explain these two reactions.